Good morning, class. Happy Tuesday. Tuesday, it's Wednesday. Let's try that again. Good morning, class. Happy Wednesday. Today, we're going to talk about section 1.5, solving inequalities. So last class, we talked about 1.4, which was solving equations. Now we're moving into solving inequalities. Our objectives for today are to solve and graph inequalities and to write and solve compound inequalities. So let's start just a quick review of our inequalities. So first example, we have x is greater than 3. We're drawing all of these inequalities on a number line. So first thing you have to make sure is that you label your number line with the numbers that you're talking about. So x is greater than 3. Because it's greater than, we're going to have an open circle at 3 and we're shading everything to the right. So all values greater than 3 from 3.00000001 all the way to positive infinity will make this inequality true. We have to have an open circle when it is greater than because we are not including 3 in that solution set. Because if we plugged in 3 here, 3 is not greater than 3 and this would not work. For x is greater than or equal to 3. Now that we see or equal to, that means 3 is included in our solution, so we're going to have a closed circle at 3 on our number line, and we're still shading everything to the right all the way to positive infinity for this solution set. For x is less than 3, because it is less than, 3 is not included in our solution, so we have an open circle, and we're shading everything to the left all the way to negative infinity. And x is less than or equal to 3. Less than or equal to means we have a closed circle at 3, and we're shading everything to the left all the way to negative infinity. So any value that you pick out in your shaded solution will make your inequality true. Just make sure for greater than or less than, you have an open circle, greater than or equal to, and less than or equal to, you have a closed circle. And you'll notice when you're looking at your inequality, when it's written with a symbol, your symbol is going to point in the direction that you should be shading, as long as your variable is on the left. So x is greater than 3, we're shading to the right. Greater than or equal to 3, we're shading to the right. Less than 3, we're shading to the left. Less than or equal, we are shading to the left. So as long as your variable is on the left side, your inequality symbol will point in the direction that you should be shading. So let's start today by writing an inequality from a sentence. So 8 fewer than a number is at least 12. So we're going to create an inequality, but the first thing that we have to do, we need a variable. So let's say let n be a number. You can define any variable. You can use x or y. You can use m. Just make sure that you define that variable so we know what you're talking about. Now we have 8 fewer than a number. 8 fewer than a number means that we're taking a number and subtracting 8. So fewer than means that you have this value comes after your variable. Is at least 12. At least 12 means that part of our solution can be 12 or greater. So our inequality symbol is going to be greater than or equal to 12. And that's our final inequality based off of this sentence. Let's try another example. Take a second, you can pause this video and try this one on your own. Write an inequality for the quotient of a number and 12 is no more than 6. So first we are going to define a variable. So let's say let x be a number. Now, the first part of our expression, we have a quotient of a number and 12. Quotient means that we are dividing. So we're going to have x divided by 12 is no more than 6. No more than means that we can have a value less than or equal to 6. So this can be a little bit confusing because no more than has the word more. You would think that it's going to be greater than, but no more than actually means that our values are less than or equal to 6. Okay, so let's think about it. This is an actual picture of me thinking. Looks great. Are the steps of solving an equation the same as the steps of solving an inequality? Think about that for a second. The only thing that changes from your equation to your inequality is the symbol. Equation means you're using an equal sign. Inequality means you're using an inequality symbol, such as greater than, less than, greater than or equal to, less than or equal to. So the only thing that's changing is the symbol. We can solve these problems in the same exact way. You're using the same method as when you're solving an equation. Let's look at an example. So we've solved and graphed the inequality. X plus 7 is greater than or equal to 8. So forgetting about this inequality symbol for a second, we're just trying to isolate our variable with it, which is x, using inverse operations. So x plus 7, to get rid of 7, we're going to subtract 7 from both sides, and we're left with x is greater than or equal to 1. So all values of x that we plug in back into this inequality that are greater than or equal to 1 will make this inequality true. So we've solved our inequality, now we have to graph. Because we're using 1, I'll put 1 in the middle of my number line, and then I'm just going to add a few numbers to the right and to the left. So 5 numbers is fine when you're graphing your inequality in a number line. Now to graph, x is greater than or equal to 1. Because it is greater than or equal to, that means we have a closed circle at 1, and we are shading everything to the right. So any of these values that we plug in, say we plug in 3, for x, 3 plus 7 is greater than or equal to 8. 3 plus 7 is greater than or equal to 8, so this is true. So you can always check by plugging in one of your solutions. Another example for solving the inequality. Take a second, you can pause this video and try it out. We have 2 times x minus 2 is less than 6. So like you saw in the last section, there are 2 ways that we can go about solving this problem. You can distribute that 2 into the parentheses, or you can start by dividing 2. If possible, I would always suggest dividing. That's going to make your number smaller, and it'll just make your equation a little bit easier to work with. So when we divide both sides by 2, we're left with x minus 2 is less than 3. Now this is just a one-step equation. Inverse operation of minus 2 is plus 2 to both sides. These cancel out, and we're left with x is less than 5. So this is our solution. When we graph, we have 5. Less than 5 means that we have a open circle at 5 on our number line, and we're shading everything to the left towards negative infinity. So every value works from 4.99999 all the way to negative infinity. That will make this inequality true. Another example, we have solve and graph the inequality. Negative 3 times 2x minus 5 plus 1 is greater than or equal to 4. Now we have a couple of different terms on the left side. When you're solving equations, remember, for simplifying, we use PEMDAS, right? That is the acronym that we use when we're solving. Parentheses, exponent, multiplication, division, addition, subtraction. When you're solving, you're working backwards from PEMDAS. So we're working in the reverse order. So when we're solving, we want to try and get rid of any subtraction or addition first, then worry about multiplication and division, then we think about exponents. So on the left side, we have negative 3 times x plus 2 minus 5 plus 1. So working backwards, we want to get rid of this plus 1 first. So we're going to subtract 1 from both sides. When we do that, we're left with negative 3 times 2x minus 5 is greater than or equal to 3. So next, we're going to think about multiplication and division. Negative 3 times 2x minus 5 is greater than or equal to 3. You can distribute or you can divide both sides right away by negative 3. Now be careful. This is our special case when we're talking about inequalities. The only difference between solving for an equation and solving for an inequality is if you multiply or divide by negative 1. When you multiply or divide by negative 1, you flip the symbol of your inequality. That's very important. Copy that down, put stars, underline, exclamation points, whatever you need to remember. So when we simplify this, negative 3 cancels out. We have 2x minus 5. Because I divided by a negative number, my inequality symbol flips. So I have less than or equal to negative 1. That is very, very important when you're solving. Otherwise, you will not get the correct solution. Now we have a two-step inequality. 2x minus 5 is less than or equal to negative 1. So we're going to add 5 to both sides. When we add 5 to both sides, we're left with 2x is less than or equal to 4. Last step to solve this inequality, divide both sides by 2, and our final solution is x is less than or equal to 2. And you can always double check. When you have your x values, your range of solutions, you can plug back into the original and make sure that it works. So now when we graph, we have 2, 3, 4, 5, 1, and 0. X is less than or equal to 2. Less than or equal to means that we have a closed circle at 2, and we're shading everything to the left all the way to negative infinity. Okay, so make sure you make a note. You always have to flip the symbol if you're multiplying or dividing by a negative number. Oh, and I erased my answer down here, sorry. X is less than or equal to 2. Okay, so next we have everybody's favorite, a word problem, using an inequality. So a video game rental company offers 2 subscriptions. You can pay $36 a month and rent as many video games desired, or you can pay $15 a month and $1.50 to rent each video game. How many video games must you rent a month for the first plan to cost less than the second plan? So we have to determine which plan works better based off of how many video games you buy. So from this word problem, we know that we want the first plan to cost less than the second plan. So plan 1, we want it to be less than plan 2. Plan 1 tells us that we pay a flat rate of $36 a month. So plan 1 is just $36 per month, and that's all we have to pay. That needs to be less than plan 2, which is $15 a month as a flat rate, plus $1.50 to rent each video game. So we're paying $15 plus $1.50 per video game. So we're going to solve this inequality now that we have it set up. We're solving for v, so we need to isolate v. To get v by itself, first thing we have to do is get rid of this 15. So subtract 15 from both sides. When we do that, we have 21 is less than 1.5v. Last step to isolate v, divide both sides by 1.5. When you divide both sides by 1.5, you get 14 is less than v. So our inequality, our solution is 14 is less than v. But remember, we always read left to right, so we want our variable to be on the left side. So I'm going to flip this around so it says v, and when you flip it now, you have to flip your symbol. V is greater than 14. So I just flipped my variable and my constant, and then I changed the sign to make it make sense the same way. So v has to be greater than 14. The question was, how many video games must you rent in a month for the first plan to cost less than the second plan? You must rent more than 14 video games. So you must rent 14 video games per month for plan 1 to cost less than plan 2. So we have a couple more examples left in this section. First, we're going to solve the inequality. Now we're not graphing on our number line, we're just solving these inequalities. So we have 6 times m plus 2 is less than 6 times m minus 3. Right away, we are able to divide both sides by 6, which will make our inequality a little bit easier to work with. When you divide both sides by 6, we have m plus 2 is less than m minus 3. Subtract m from both sides. Both of these cancel out, and now we're left with 2 is less than negative 3. 2 is less than negative 3. 2 is not less than negative 3, so that means that this inequality has no solution. So it is possible, just like our equations, it is possible to have no solution when we're talking about inequalities. There is no value that we can plug in for m that will make this inequality true. Let's look at another example. Solve the inequality 5 times 2d minus 3 minus 7d is less than or equal to 3d plus 8. You can pause the video and try this problem on your own. So the first thing we're going to do, we cannot, there's no common factor among all of our terms, so we can't divide first. So we're going to have to distribute this 5. When we distribute the 5, we get 10d minus 15 minus 7d is less than or equal to 3d plus 8. On the left side of our equation, we can combine like terms. We have 10d and negative 7d. That gives us 3d minus 15 is less than or equal to 3d plus 8. When we move our variables to the same side, subtract 3d from both sides, all of our variables cancel out in this case, and we're left with negative 15 is less than or equal to 8. Negative 15 is less than or equal to 8, so this is true. So this inequality is always true. For any value that you plug in for d, you will always make this inequality true. So we can write our solution as all real numbers. And the symbol for all real numbers, if you just want to write that, is your r with 2 legs coming down. So any value that we plug in for d is going to make this inequality true. Another example, solve the inequality. We have 4 times 2x minus 3 is less than 8 times x plus 1. Notice right away we can divide both sides by 4. When we do that, we have 2x minus 3 is less than 2 times x plus 1. So right away, that just makes our numbers a little bit easier to work with. Next, we have to distribute this 2. When we distribute the 2, we have 2x minus 3 is less than 2x plus 2. Next, we're going to move our variables to the same side of the inequality symbol. So subtract 2x from both sides, and all of our variables cancel out. When we do that, we're left with negative 3 is less than positive 2. Negative 3 is less than positive 2. This is a true inequality, which means our solution is going to be all real numbers again. So the only way that you can get all real numbers or no solution is when your variables cancel out. So next we're going to talk about compound inequalities. You can join two inequalities with the word and or the word or to form a compound inequality. To solve a compound inequality containing and, find all the values of the variable to make both inequalities true. So we have an and an or inequality. When you're graphing an and inequality on a number line, your shading should look something like this, where you have your 2 points and you're shading everything in between those two solutions that you figured out by solving. So and usually means things are together, we like them, so that shading should be in between going towards each other. For or, on the other hand, wherever you have your two solution points, you are going to shade in opposite directions. So your shading should not go towards each other. Or you like vanilla ice cream or chocolate ice cream. You don't like both. So you're going in opposite directions when you're shading for or. So let's look at an example. What is the solution of 7 is less than 2x plus h and 3h is less than or equal to 18? So we have an and, so our shading should be going towards each other. So now we have two inequalities. We can solve both of those separately. First, we have 7 is less than 2h plus 1. We want to isolate 2h, so we're going to subtract 1 from both sides. When we do that, we have 6 is less than 2h. Last step to get h by itself, divide both sides by 2, and we have 3 is less than h. Or we can flip it around so that when we're reading it, it makes sense. So h is going to be greater than 3. For our second inequality, we have 3h is less than or equal to 18. To isolate h, we just divide both sides by 3, and we have h is less than or equal to 6. So these are all values of h greater than 3 or less than or equal to 6 are going to make both of these inequalities true. So when we're shading, let's see, we need 2, 3, 4, 5. Let me move this down. Okay, so when we're shading, I'm going to shade off the number line first so that you can see, make sure our shading overlaps. So for h is greater than 3, greater than 3 means we're going to have an open circle at 3, and we're shading everything to the right. For h is less than or equal to 6, less than or equal to means we're going to have a closed circle at 6, and we're shading everything to the left. Remember, when we're talking about and, it has to make both inequalities true. So we're looking for the space where both of our solution sets overlap. So that's going to be just between 3 and 6. So when we bring this to our number line, we're going to have an open circle at 3 because h is still greater than 3, a closed circle at 6, and we're shading everything in between these values. So all values from 3.0001 all the way up to 6 make both of these inequalities true. Our last example for this section, what is the solution of 7 plus k is greater than or equal to 6, or 8 plus k is less than 3? So for or, our shading is going to be going in opposite directions. So let's solve the first inequality. 7 plus k is greater than or equal to 6. Subtract 7 from both sides to isolate k, and we're going to have k is greater than or equal to -1. For 8 plus k is less than 3, subtract 8 from both sides, and we're left with k is less than -5. So on our number line, we have -5. Okay, so we have our number line. For k is greater than or equal to -1, that means we have a closed circle at -1, and we're shading all values greater than -1. For k is less than -5, we're going to have an open circle at -5 because that's not included in our solution set, and we're going to be shading everything to the left. So be mindful when you're shading compound inequalities on the same number line, please be mindful of whether you have a closed circle or an open circle. If it's or, your shading should be going in opposite directions and should be shaded in the same direction. Okay, so that is it for this section. Your homework for tonight, and you can start it now if you have remaining time in the period, page 38, 11, 17, 23, 24, 27, 31, 43, 47, and 54. Again, just like you did last time, please write this on a piece of paper, turn your paper into a PDF, and then upload it to Google Classroom, and I will check it there. Okay, if you have any questions, feel free to unmute yourself and ask. You can type it in the chat, or you can email me if that feels more comfortable. Okay, have a great day. Good luck.